Number 6, if f of x equals the cosine of square root of x over the square root of x, what is the average value of f of x from x equals pi squared over 9 to x equals pi squared over 4? So this is an average value problem. So average value, I know the second I see that it's 1 over b minus a times the integral from a to b of my function. Okay, so setting this up, I'm going to have 1 over a over b. This would be my a, and this would be my b. So it's going to be pi squared over 4 minus pi squared over 9 times the integral from pi squared over 9 to pi squared over 4 of the cosine of the square root of x over the square root of x dx. All right, from here, unfortunately, this is a non-calculator problem, so we're just going to plug through and do the best that we can. First thing that I'm going to do is take care of this fraction out front. I'm going to get a common denominator, which would be 36. So it's going to be 1 over 36 I'd have to multiply this first fraction by 9, so I'm going to get 9 pi squared, and then minus, I'd have to multiply the second fraction by 4 over 4, so I'm going to get minus 4 pi squared, and then from here I'm going to have 1 over 5 pi squared over 36, and then if I multiply by the reciprocal, that will end up equaling 36 over 5 pi squared. Okay, so great. Now we still have the whole rest of the problem that we get to tackle here. And we don't get to use our calculator again, so we're just going to keep plugging through. This one, if there is a trig function in my integral, I basically always want to let the u be what's right next to it. So we're going to let u equal the square root of x. And another way of writing that would be x to the 1/2. And so my du is going to be 1/2 x to the negative 1/2, and that would reduce to 1 over 2 square root of x dx. And you'll notice I do have the square root of x down below, just like I would wanted to, but I need the 1/2. And so if I put a 1/2 on the inside, I need to put a 2 on the outside to undo it. So I now have 72 over 5 pi squared. And then this would now be cosine of u du. And then from here, the integral of cosine is sine. So I'm going to have 72 over 5 pi squared sine of u, and u again is the square root of x, and we're going to evaluate it at pi squared over 4 and pi squared, that's a 4, and pi squared over 9. Okay, so we're going to have 72 over 5 pi squared sine the square root of pi squared over 4 would be pi over 2, and then minus 72 5 pi squared sine the square root of pi squared over 9 would be pi over 3. Okay, so we are almost here. All right, so the sine of pi over 2, if you're thinking about, you got your hand out or however you do it, would be the y value. The sine of pi over 2 would be 1, and the sine of pi over 3 would be the square root of 3 over 2. Okay, from here, there's one more step that I'm going to do. Both of these parts, instead of trying to combine like terms or anything like that, I just noticed they both have a 72 over 5 pi squared, so I'm going to factor that out, and if I do that, I'll have 1 minus the square root of 3 over 2 left. So that would be my integral. Alrighty, number 7. Find the integral of ln to the 4th x over x dx. Alright, basically what this means, another way of writing this, I'm just going to rewrite it as the ln x of 4 over x dx. Okay, we cannot move this 4 out front because it's the entire quantity that's being raised to the 4th power, not just the x. So we're pretty much stuck. You do not know an integral for ln x, so we are actually going to do a u substitution, and we are going to let u be the natural log of x. So the derivative of ln x, hopefully we know, is 1 over x dx, and you'll notice if I put my 1 there, I do have 1 over x dx. So if I rewrite this problem, I actually have u to the 4th du. So now from here, the integral of u to the 4th would be 1/4, start that over again. That would be 1/5 u to the 5th, and then from here I'm just going to put my integral back in. That would be ln x to the 5th, and then plus c. And if I wanted to rewrite it ln to the 5th x plus c, I could do that as well. Either one of those would be totally acceptable. Right, number 8. A survey shows that a mayoral candidate is gaining votes at a rate, key there, of 2,000 T plus 1,000 votes per day, where T is the number of days since she announced her candidacy. How many supporters will the candidate have after 60 days, assuming that she had no supporters at time equals 0? Okay, how many supporters would basically mean how many votes. We know how many votes she has per day, so we want to get rid of the per day. And if you recall, to get rid of the per day, we're going to actually take the integral to go from a rate to how many we have. So I'm going to take the integral of the rate, which would be 2,000 t plus 1,000, and that would be dt. And it's over 60 days, so it's going to go from time equals 0 to time equals 60. So this will tell us how many votes that she's been gaining over those 60 days. And so if we do this, we don't get to use our calculator, which is okay. Since there's a plus sign, we can actually take the integral of each part separately. And then if I do that, the integral of 2,000t will be 1,000 t squared, plus the integral of 1,000 would be 1,000 t. Now I get to evaluate it at 60 and 0. If I plug in 60, 60 squared times 1,000 will be 3, 6, and 5 zeros. Plus, when I plug 60 in and there, I'll get 60,000. And then minus, if I plug in 0, I will get 0. So if I add those two together, I'll have 3,660,000 votes. And this said, how many supporters will she have after 6 days? One thing I just need to check, this is how many supporters she has gained. Since she didn't have any supporters at time equals 0, this is how many votes or supporters she will now have. Just one comment, if it said like she started with 50 supporters, then I'd have to add 50 to my answer to get my total final answer. Okay, question 9. If f of x equals the integral from 4 to x of 5 over the cube root, the square root of x cubed plus 1, then f prime of 2 is equal to what? So on this problem, they're asking me to find the derivative of an integral. And I know when we're finding the derivative of the integral, as long as this goes from a constant to a variable, which it does, then we can use the second fundamental theorem of calculus, which basically just states that the derivative and the integral will cancel each other out. We will replace the, I guess this should have been a t actually, we will replace the t with an x. So when we do this, we'll get f prime of x is going to equal 5 over x cubed plus 1. And that pretty much does it for me. One thing we might want to check, we do always want to multiply by the derivative up here, and this just happens to be 1 in this case, so I'm all set. And then it asked me to find the derivative at 2. So the next thing that I do need to do is actually plug in 2 for my x. And when I do that, I will get 5 over the square root of 9, and that will reduce to 5/3. Okay, problem 10. Find the integral of dx over the fourth root of a plus bx cubed. So this might look like a mess, but I'm going to first of all just rewrite down below as a power. This would actually be a plus bx to the 3/4 power, because you do the power over the root. And then from here, I'm actually going to take it one step farther. I'm going to rewrite it as a plus bx to the negative 3/4 dx. Now from here, since I have parentheses, I know that I'd like to do a u substitution. So we'll let u equal a plus bx. And even though a and b might be kind of scaring you, they're just constant. So pretend like they're 3's or 1's or 2's or whatever. The derivative of a, since it's a constant, is 0. The derivative of bx would just be b dx. Notice I have the dx, but I don't have the b. So I'm going to put a b on the inside and a 1 over b on the outside. So if I rewrite this, I have 1 over b, and my integral will now be u to the negative 3/4 du. Notice it's not du over u, it's to a certain power. So now, when we do this, we always add 1 to the power, so this will be u to the negative 3/4 plus 1 would be 1/4, and then we always do the reciprocal on the outside. So I would be left with 4 over b, and then my u would be a plus bx, and that's raised to the 1/4 power, and then plus c. And then that would be my answer.